Hello students, now we are going to start problem based on gravity and gravitation from competitive exams and some important problems. First problem they gave you the largest and the shortest distance of the earth from the sun are R1 and R2. Its distance from the sun when it is perpendicular to the major axis of the orbit drawn from the sun is. Actually, it is only related to Kepler's law. What Kepler told us? That planets are moving in elliptical orbits. So it is based on the property of ellipse. See, we know that Earth is revolving around the sun in elliptical orbit. It is an ellipse. And sun is at one of the focus. Focus is on major axis. It is major axis. It is minor axis. You know the equation of ellipse, x square upon a square plus y square upon b square is equals to 1. If center is 0, 0 and these axes are x-axis and y-axis. This is semi-minor axis, its length is b. It is semi-major axis, its length is a. Now what they are saying, the largest and the shortest distance, definitely shortest distance if planet is at this point. Shortest distance when planet is at this point, and largest distance when planet is at this point. These are the shortest and largest distances. So these they are given R1 and R2. What they are saying, this distance is R1 and this distance is R2. What is the property of ellipse? To any focal chord, focus is dividing in a ratio. Means if focal chord, what is the focal chord? Any chord which is passing through focus is known as focal chord. And focus is dividing this focal chord into two parts. It is ellipse property that the harmonic mean of these two parts should be equal to minor axis. And what they are saying, when it is perpendicular to the major axis, when it is perpendicular to the major axis means at this point, the largest and the shortest distance of the earth from the sun are R1 and R2. Its distance from the sun when it is perpendicular to the major axis or the orbit drawn from the sun is, suppose it is R, we are taking it R. It should be harmonic mean of these two parts of focal chord, means 1 upon R1. Harmonic mean means 2 upon R should be equal to 1 upon R1 plus 1 upon R2. So what we are getting? 2 upon R is equals to R1 R2 and R1 plus R2. So what we are getting are 2 R1 R2 divided by R1 plus R2. This property of ellipse. So we are going with C. Next, the distance of two planets from the sun are 10 to the power 13 meter and 10 to the power 12 meter. The ratio of time period, again problem based on Kepler's law. We know that T square should be proportional to R cube. What we know that? T square should be proportional to R cube. Kepler's law. It means for each and every planet, the ratio of square of time and the cube of radius, it should be equal, constant. It should be equal means constant. What is t square? Suppose for first planet I am taking it t1 and constant I am taking k. Radius, the distance they are saying 10 to the power 13 cube. For second planet, t2 square constant, it is at 10 to the power 12. So what we are getting? We are getting t1 square divided by t2 square is equals to 10 to the power 39 divided by 10 to the power 36 means 10 to the power 3. Taking square root, what we are getting? T1 by T2 square root of 1000 means 10 root 10. So we are going with option B. The period of revolution of planet A around the sun is 8 times that of B. The distance of A from the sun is how many times greater than that of B from the sun? The period of revolution of planet A around the sun is 8 times that of B. The distance of A from the sun is how many times greater than that of B from the sun? Again, it is based on Kepler's law. What is Kepler's law? T square is proportional to R cube. It means for each and every planet, T square upon R cube should be constant. For planet A, I am taking TTA. Radius, I am taking RA. You can say radius, distance between sun and planet. For planet B, it should be RB cube. What we want to calculate? The distance of A is how many times greater than that of B? Means we want to calculate RA upon RB. We want to calculate RA upon RB. What is given? The time period of revolution of planet A is 8 times that of planet B. It means TA by TB, it should be 8. It should be 8. So I am using this result now. What is RA cube by RB cube? RA cube by RB cube is equals to TA square by TB square means TA by TB whole square. What is TA by TB? it is 8. So 8 square means 64. Taking cube root, we are getting RA by RB is equals to cube root of 64. What is cube root of 64? 64 is 4 cube. So we are getting 4. So we are going with option A. We are going with option A. In 2009, in AIPMT, they gave this problem which we discussed in our theory part. The figure shows elliptical orbit of a planet M about the Sun S. The shaded area SCD is twice the shaded area SAB. If T1 is the time for the planet to move from C to D, T2 is the time to move from A to B, then I told you that in same interval of time, it will travel the same area. Means the ratio of area traveled is equals to ratio of time. Means in same time interval it will travel same ratio of same area. What they are saying कि in SCD, so area of if SCD area, we take half of this area, what we will see कि half area it will travel in how much time? C to D it take T2 time. So half area it will travel in T2 by 2 time. And again here A to B, the shaded area SCD is twice the shaded area SAB. Okay, they are saying T1 is the time for the planet to move from C to D. It is not T2. This time they say T1. C to D time is T1 and A to B time is T2. So ratio of area traveled is equals to ratio of time. It means area of SCD upon area of SAB is equals to SCD time is T1. It is T1 given. Wrongly I write it T2, but it was T1. That time they say T2. So what is this? This area is twice the area of SAB divided by area of SAB. SAB. And T1 upon T2. Cancel this with this. So we got T1 is equals to TT2. So we are going with option B. Kepler's second law. Next, two particles of equal mass go around a circle of radius r under the action of their mutual gravitational force of attraction. The speed v of each particle is. So problem is very simple. What Earth is revolving around the Sun due to the mutual attraction between Earth and Sun. What it is getting? For revolving around the planet, for revolving, satellites are revolving around the planets. They are getting their centripetal force from attraction between planet and satellite. Planets are orbiting around the Sun. it is getting centripetal force from the attraction between sun and planet. Same phenomena is here. The two particles attracting each other. Equal mass, and they are moving in equal radius. It is moving in this circle, it is moving in the same radius. The mass of two particles is m. So move in radius of circle r. Both needs a gravitation, centripetal force mv square by r. From where they will get it? They will get it from mutual gravitational attraction between the particles. What is mutual gravitational attraction? G m1 m2 upon r square. So what we are getting? Cancel m with m. R with 1 r. Okay, first we will open the bracket. So we are getting v square is equals to gm, take this r in numerator, upon 4 r square, cancel 1 r now. So what we are getting? 1 by 2 root gm by r. So we are getting B option. Next. So what is happening here? We want to calculate. What is the problem? It is from 1995 AIPMT. The earth revolves round the sun, angular velocity is given, radius of orbit is given. We want to calculate force exerted by the sun on the earth. We can calculate force by Newton's law of gravitation. In that case, we need the mass of sun, which is not given. Suppose I gave you 100 rupees and you spent that 100 rupees in some shop. If I know what rupees you spent in that shop, I can calculate what I gave you. Are you getting my point? It is not necessary that I should know what I gave you. Or A gave some money to B and B spent whole money in a shop C. What A gave to B, I can calculate from C. What money B spent at shop C, it was given by A. Same thing is here. Sun is applying a force on earth. Earth is spending this force in orbiting around the sun, because if you want to orbiting around anything in a circle, any object which is moving in a circle needs centripetal force. And from where he is getting that centripetal force? In this case, he is getting from the force which sun is exerting on earth. So I will calculate what force sun is exerting on earth by the calculation of what force earth is using for orbiting around the sun, that is centripetal force mv square by r. What is V? Omega square r. V is omega into r, so V square omega square r square. So all things are given now, so we can write this. M 6 into 10 to the power 24 kg. What is omega? 2 into 10 to the power minus 7. 2 into 10 to the power minus 7. What is R? 1.5 into 10 to the power 8. But it is in kilometer, so convert in meter, because all other physical quantities were in SI units and we need force in Newton so that we can write it Newton. Calculation is simple. 6 into 2, 12. 12 into 2, 24. 24 into 1.4 means 24 and half, 36. So number we are getting 36 into 10 to the power 24 plus 14 minus means 10. 10 and 8, 18 and 3, 21. So number is 21. So we are going with option D. So we are getting answer D. Gravitational force is required for stirring of liquid, convection, conduction and radiation. You know that in a radiation, no medium is required. In conduction, no use of gravity. Every particle is supplying energy to nearby particle. But when you are heating a liquid, what is happening? By heating, the particle become lighter and it will move to the upper part, and heavier particle due to gravity will come down. Means gravity is used in the method of convection. So gravitational forces are required for convection. Next, it is from 2000 AIPMT. A body of weight 72 Newton moves from the surface of Earth at a height half of the radius of the Earth. The gravitational force exerted on it will be. We can calculate by change in potential energy. The body of weight 72 Newton moves from the surface of Earth at a height half of the radius of the Earth. What do you mean by half? The value of G will change there. We can calculate with the help of gravitational potential energy at the surface of Earth. In this way, we are able to calculate the value of G. What is the gravitational potential energy at this place? Minus G M by RE by GMM by RE. When we move at a height equal to half of the radius of Earth, now distance from the center is 3r by 2. It was PE1. Now at this place, potential energy should be minus GMM distance is 3RE by 2, because R will become distance between this point and Earth center is now 3R by 2. So what is the new potential energy now? 2 by 3 minus 2 by 3 GMEM by RE. What is change in potential energy? Minus 2 by 3 GMEM by RE. Minus minus plus GMEM by RE. Take GMEM common. So what we are getting, 1 minus 2 by 3 is 1 by 3. What is GME? It is GRE square. It is mg Re divided by 3. mg Re divided by 3. So it means, what is the change in kinetic energy? It was minus gme m by Re at this place. Now it will become change in kinetic energy is this. So weight of body on Earth's surface was 72 Newton. Weight is due to gravitational force. It was mg. It was 72 Newton on surface of Earth. But when we went to the height h, r by 2, there is a decrease in the value of g. What is the, it is change in potential energy. And what is the change in value of g? We know that the value of g at that place, first we put on Earth's surface, it was gme divided by re square. At that point, it is, I am taking g dash, gme divided by re plus re by 2, 3 re by 2 means 9 re square by 4. So it means value of g dash is decreased by 4 by 9 of the value of this on Earth's surface. So what is the value of 4 by 9 of 72? Only change in weight is due to this change in g. 9 8s, 8 4s. It should be 32 Newton. 32. So it means weight of body moves from the surface of Earth, then the gravitational force exerted on it will be, now it will become 32 Newton at that point. So if you want to calculate work done, we can calculate work done by this change in potential energy. But in this, simply we want what is the weight at that point. So there is an apparent change in the value of g. Due to apparent change, g is decreasing, so weight is decreasing. So it will become 32 Newton at that point. So we are going with option B. Ninth, two spheres of masses m and capital M are situated in air and the gravitational force between them is F. The space around the masses is now filled with a liquid of specific gravity 3. The gravitational force will now be, we know that gravitational force between two objects is unaffected by any third particle, any third surrounding mediums. In Newton's law of gravitation, there was no space for what is medium between these two. When we were discussing about Coulombian force in electricity, we put 1 upon 4 pi epsilon naught, and we discussed there epsilon naught is the permittivity of free space. When we were discussing about magnetic force between two poles, we put there mu naught upon 4 pi, and we said there कि mu naught is permeability of free space. If there is no free space, mu naught will become mu, epsilon naught become epsilon, because in that place medium matters. But in Newton's law of gravitation, force between two objects, there were no role of medium. So this force will be unchanged. So we are going with B. Next, the radius of Earth is about 6,400 kilometer, okay, and that of Mars is 32,100 kilometer. The mass of Earth is about 10 times mass of Mars. An object weighs 200 Newton on the surface of Earth. Its weight on the surface of Mars will be, again, same type of problem which we discussed in 8th. In 8th problem, you were taking an object from at a distance from Earth's surface. So value of g was decreasing. Due to that, there was decrease in the weight. Weight means gravitational force. Same is here. You are taking one object on Mars. Definitely, acceleration due to gravity for mass is different. So its weight different there. What is weight? Weight is m into g. M matter content, same everywhere. If you are on Earth, you have to put the value of g on Earth to calculate weight. If you are on Mars, you have to put the value of g of which is the on Mars. What is the value of g? On Earth, we put it gm upon re square. What should be for Mars? In place of mass of Earth, we will put mass of Mars. In place of radius of Earth, we will put radius of Mars. So what is the difference between these two? Gm and Ge. Gm upon Ge is equals to, G will be cancelled out, mm upon rm square into re square upon me. Now what they are saying? Radius mass of Earth is 10 times that mass of Mars. Means I am taking mass of Mars mm, so mass of Earth should be 10 times of it. Radius of Earth is given 6,400 kilometer. Not changing the unit in numerator and denominator, I am putting same unit, unit will cancel out. 3,200 for Mars. So what we are getting, cancel this with this. We will get 2. We will get 2. 4 upon 10 means 1 upon 2.5. It means the value of g is 1 upon 2.5 times the value of g on Earth. Multiplying both sides by m, we can calculate mass weight of object on Mars, because we know the weight of object on Earth. mge is given 200 Newton. So 200 by 2.5. Remove this decimal, you will get 1 0. 25 8s are. So what I am getting? 80 Newton. So on Mars, it will weigh 80 Newton. So we are going with C. 11th. It is from 1995. It is from 1995 AIPMT. The acceleration due to gravity g and mean density of Earth rho are related by which of the following relations? We know that the value of g at Earth's surface is g mass of Earth upon radius of Earth. They are saying radius of Earth r. We know that assuming Earth spherical, mass should be volume into density, and volume of sphere you learned in 8th class 4 upon 3 pi r cube. Volume into density, again formula for 9th class. Cancel 2r. What you are getting? You are getting 4 by 3 pi r rho g, rho g. But in 4 options, they are putting rho on one side. So what we are getting, rho is equals to 3g upon 4 pi r capital G. So 3g upon 4 pi 3g 4 pi r g. So we are going with option A. What will be the formula of mass of the earth in terms of g, r and capital G? Again, very simple formula. We know that g is equals to gm by r square. So mass of earth should be equal to gr square by g, r square by g. So going with B. Next, the acceleration due to gravity on the planet A is 9 times the acceleration due to gravity on the planet B. A man jumps to a height of 2 meters on the surface of A. What is the height of jump by the same person on the planet B? See, when you are jumping, what you are doing? You are converting your internal biochemical energy, which you got from the food, into potential energy. Suppose you jumped up to a height h, from where you gain this mgh potential energy. You used your internal biochemical energy, so you have that much energy on both planets. So on Earth, up to what height you can go? So first we will discuss on planet A. We are discussing on planet A. Suppose your mass is m and acceleration due to gravity is g on planet A, and you jumped up to a height of 2 meters. So mgh, energy used by you, is 2 mga. Now same energy you are using on that planet, but you are the same person, so your mass is same m, but acceleration due to gravity at that planet is different, so you will go up to a different height h. You use same E, so we are writing here 2gam, same energy you used there, mgb into h. Cancel m with m. They gave Ga is 9 times the acceleration due to gravity on planet B. Ga is 9 times Gb. Cancel Gb with Gb. What you are getting at that planet, you can jump up to a height of 18 meters. With that energy, you can go up to 18 meters. Next, the density of a newly discovered planet is twice that of Earth. The acceleration due to gravity at the surface of the planet is equal to that at the surface of the Earth. If the radius of the Earth is r, the radius of planet would be. So from where we should start? What is the key point? The key point is here. It is a problem from 2004 AIPMT. The key point is this: the acceleration due to gravity at the surface of the planet is equal to that at the surface of the Earth. So we will start from here. acceleration due to gravity on Earth is equals to same the acceleration due to gravity on the surface of planet. But what is the formula for G? It is capital G. First I am talking about Earth. So I am taking mass of Earth upon radius of Earth whole square. G is everywhere same. That's why it is known as universal gravitational constant. But I am talking about planet, so I have to take mass of planet. I have to take radius of planet. But no role of mass in this problem. They are talking about gravity, they are talking about density, but presently we have no density here. So what I should do? Change this formula in terms of gravity. So I am using mensuration of class 8 plus a little bit knowledge of class 9th. What is the relation between mass and density? Mass is volume into density, and since shape of planets we are assuming spherical, so volume is 4 upon 3 pi r cube into density. It is Earth, so I am writing density of Earth upon Re square for that planet. Mass 4 upon 3 pi Re cube, density of that planet's material. R I am using, that is planet, so P, Rp, cancel 2 Re, cancel 2 Re with 2 Re, Rp square, cancel 2 Rp with 2 Rp, G with G, 4, 3 and pi with 4, 3 and pi. So what we are getting? This side Re, rho e, and on that side Rp, rho p. What they are saying, the density of newly discovered planet is twice that of Earth. Given density of planet is twice that of density of Earth. Putting in this Re, radius of Earth, density of Earth, for that planet, radius of planet, density is twice the density of Earth, cancel rho e with rho e. So what we are getting? The radius of planet is half the radius of Earth. So we are going with option D, because radius of Earth is given R. So radius of planet should be R by 2. So problem was not very tough, only simple concepts we use in this. Imagine a new planet having the same density as that of Earth, but it is 3 times bigger than the Earth's size. If the acceleration due to gravity on the surface of Earth and that on the surface of the new planet is G dash, we want to relate G dash with G. Same type of problem, little bit different calculation. What is G? Gm by R square. But they are talking about density, so change in terms of density. Again mass 4 upon 3 pi r cube, volume into density upon Re square. So for formula of gravitation in terms of gravity density, 4 by 3 pi g r e into rho. Now what they are saying, new planet having the same density as that of Earth. So what should be for that planet, using same result for that planet? So I am getting 4 upon 3 pi g for planet RP into it should, if it is rho e, for planet we have to use rho p. Now what things are given? They are saying 4 upon 3 is constant, no problem. Pi is constant, g is constant. Density is same that of Earth, so we are writing rho e. Having the same density but 3 times bigger than the Earth in size. What do you mean by 3 times bigger? It means the size is 3 times. Means the radius should be 3 times. And radius are playing a role in numerator only. So for planet, size is 3 times bigger. So we are putting 3RE. So what we are getting? All physical quantities which we used in G, only extra 3 is there. So we are writing 3G. So we got the option D. Next, it is from 2003 AIPMT. A body of mass m is placed on the Earth's surface. It is taken from the Earth's surface to a height h, 3r. The change in gravitational potential energy of the body is a direct problem because we know the formula of potential energy. We are assuming Earth's surface first, we are calculating minus G m mass of Earth, mass of object upon r, because it was at a distance r from Earth's center and Earth's mass is assuming at its center only. Now potential energy is changed because there is a change in distance between object and Earth's center. Mass of Earth same, mass of object same. Now we take it at a height 3r. So now it will become 3r plus r, from Earth's center 4r. So what is change in potential energy? PE2 minus PE1. It is the change in potential energy. What is PE2? Minus GMEM upon 4RE, minus minus plus GME M upon RE. Take GME upon RE common. Minus 1 by 4 plus R plus 1. So it is 3 by 4. Put GME, GRE square. Cancel 1 RE. So what we are getting? 3 by 4 MGRE. So we are going with A. In next slides, we will discuss remaining problems.